exploit, I get script in there. Anybody who views this script, I use Ajax to blindly infect maybe their custom stock ticker or post a message to a forum, something. I propagate it. Now, hopefully, if you are a stock trading site, the place where your forum is a different subdomain than your stock trading site, so Ajax couldn't talk. But we saw with MySpace, they had profiles and www, but because they both pointed at the same place, I'm able to get around that. The payload is, I'm going to use Ajax to make the worst buy and sell stock trading decisions you have ever seen. Now, remember, complex confirmation pages, not a problem. Are you really sure you want to sell all your stocks of, Ford? Yes, I do. Short of a CAPTCHA, actually E-Trade. E-Trade actually implemented two-factor authentication. Our VP of product management is here, Eric Peterson, and he actually, when I was giving this talk back in January, he held up this little secure ID token he got from E-Trade. And he said, yes, E-Trade, whenever you do a stock trade, you enter in the little number that's on there. And I had read about this, and apparently E-Trade, they'll give those to you for free if you have more than $50,000 invested with them. Or you can pay, $100 and just get one. And so I'm like, so Eric, do you have $50,000 invested with E-Trade, or did you pay the money? He's like, I don't think I'm going to tell you that, Billy. But this is very good, and I applaud E-Trade. This is a good step. Two-factor authentication, when you're dealing with money, is a very, very good idea. So they should be applauded for this, because I'm not saying any of these people are infected, but if E-Trade did have a cross-site scripting vulnerability, I'm not joking, I'm not even trying to insinuate that any of these people do, but if they did, the two-factor authentication would prevent something like this from happening. So 2 modes. The virus is going to have 2 modes. It's going to have online mode, where it actually contacts a third party, and the third party can just massively tell all these bots that report into it, sell Ford now, or buy Ford now, or do whatever. Also has research mode. Let's say the virus, for whatever reason, can't contact a master to tell it what to do. This was a fun computer science project. How can something decide what really good and bad stock trading decisions to make? So it goes into research mode. Online mode, like we said, we use fingerprinting, whatever. I could simultaneously damage thousands of portfolios by giving them a really bad choice. Or I put them in research mode where they figure out it themselves. So what I could do is I could use a random string and just randomly build a stock trading symbol. And then I start using Ajax to sample the price of that stock at known intervals. And then what I do is I take a derivative, which gives me the rate of change. How quickly is the price fluctuating? How quickly is it increasing? Is it at the top of a curve, or is it at the bottom of a curve? So I can figure out when a price is about to kind of stabilize or when it's going up. I mean, I'm not figuring out how to win the stock market. These are just very simple math equations. And so I'm going to figure out right when your price starts going down and accelerating, meaning it's really expensive, I'm going to tell you to buy more shares of it because it's dropping in price. So let's buy it when it's really, really expensive. And when you're at the bottom of that curve and it's about to start having a rebound, because Ford, in fact, said we do have a strategy not to, bottom out, I'm going to start selling your shares when they're rock bottom prices, when they're basically chunk bonds. So what's the impact of this? Try explaining to the SEC that you did not make that stock trade because it came from your IP. You were online, you logged in, and your trades you were doing, your legitimate trades, are mixed in with the trades the virus is making. Eventually, let's assume the stock trading site, they find the virus and they remove it. And they attempt to sort out the real trades from the virus trades. It really doesn't matter in the end. I mean, as long as I get even a couple of days of the virus making trades, external brokerage houses, external people, the virus is going to be affecting the market. How much so? I don't really know. But external people are going to make buy and sell decisions based on the buy and sell decisions that a giant block of fictitious E-Trade users are now making. And while you can roll back the clock for everybody on E-Trade said, yeah, you guys got owned, you didn't really do this, you can't give your money back to the people managing hedge funds or all the other people who were day trading that day. So this is where it gets really scary, because JavaScript, that thing that hijacks sessions and pop-ups, that just made and infected the stock market. That's pretty scary. So how do you fix all this stuff? I mean, yeah, doom and gloom. This is it's kind of fun to think evil. How would I destroy stuff? But seriously, we got to grow up. We can't all be 13-year-old people doing DDoS attacks. How do we actually fix this stuff? Well, ultimately, web malware is occurring because I'm exploiting web vulnerabilities, right? I'm either doing cross-site scripting to facilitate a web worm, or a web virus, or I'm doing remote code execution to do a web virus. Web virus for cross-site scripting, web worm for execution. So if you're fixing the vulnerability, it really stops both aspects of web malware. It stops further injection and further propagation. It also stops payload execution. So once you fix these things, everything stops, and you win. Really, your web application are like bricks in the wall. They build your website, it's the bricks. Do you really trust a brick you downloaded from SourceForge? I contribute to a lot of SourceForge projects. I enjoy it. I love SourceForge. It's great. But seriously, if you're a company and you've got applications that are important, do you really want to go grab some forum software off SourceForge and stick it on there? Your web app is only as secure as its weakest link. And a lot of times the weakest link is some piece of software you downloaded and you didn't really understand and probably hasn't been maintained in a couple of years that's rife with cross-site scripting vulnerabilities. So again, 90% of web application security is all about validating the input. Never, never, never trust anything you get from the client. I can spoof, lie, steal, do everything I can. You simply can't trust me. Hidden input forms, cookies, URL, post data, even HTTP headers. I can lie about everything. So you should never use anything you get from the client without sanitizing it. Is this a zip code? Enforce those data types. Is it only supposed to be numbers? Is it only supposed to be letters? Format-wise, is this supposed to be a credit card? If so, look for dashes and actually compute the checksum. It's not very hard to do. The last digit of a credit card number is called the LON algorithm or also the mod 10 algorithm. It's really easy to compute. Verify that that's actually a credit card number. Length restrictions. I got, how many, 3 minutes? Got to tell you a fun story. You guys should go to Google and search for TinyDisk. Y'all ever heard of TinyURL? Surely you've heard of TinyURL. TinyURL allows you to submit a URL, and they give you a little hash. And then when you go to tinyurl.com/hash, they redirect you back to that URL. Wait a minute, I wrote something, then I read something back. Sounds like a file system, doesn't it? So I went and I wrote a file system that runs on top of TinyURL. And sure enough, it does work. It takes a file, compresses it, encrypts it, dices it into little pieces, submits them as URLs to TinyURL, gets back basically a list of hashes, and then it just, when it wants to reconstruct the file, it just grabs all those hashes and reconstructs the file. So because they didn't have length restriction on their application, I wrote a file system on top of somebody else's web application. This is ridiculous. But they didn't validate their input. I could give them anything. In fact, when I was messing around with this, I inadvertently uploaded all of Lewis Carroll's works to a single TinyURL hash. And when you visit TinyURL/hash, it gives you a 302, an HTTP 302, and location, and the URL. Do you have any idea what IE or Firefox does when they get 270K of data in the location header? Yeah, no, I won't, but it's there, and it's odd. So length restrictions are important. You should escape characters to avoid SQL injection. You shouldn't only escape characters, which PHP and ASP and everybody else can do it. You should use whitelisting. You should say, look, this is supposed to be a zip code. If I get anything other than a digit followed by 4 more digits, throw it out. You shouldn't say, oh, there's a tick here, or oh, there's a greater than sign. That might be SQL injection, throw it out. Because as soon as I find a new way to do SQL injection, your filter is worthless. So instead of trying to tell me what you won't accept, tell me what you will accept and throw everything else away. This is called whitelisting. Input validation should always be on client and server side. Client-side validation should solely be for performance reasons, so you don't have to cross that internet cloud. Server side should only be, it's the only sure way to enforce security. Your front-end code should properly represent your back-end code. So many times I see HTML forms that you post to a page, but actually if you send those parameters in the query string, it works just as well. Over-engineering a web app is bad. I mean, if you've got, you might want to consider having an LDAP directory instead of a fully functional relational database as your back end. If you are just serving static content and only you on the client side actually insert that data and your web app is doing lots of reads, don't use a SQL database. Use an LDAP directory. Use something that's optimized for lots of reads and hardly any writes because it's a lot easier to lock down. If you have static content, your privacy policy is probably static content. Don't serve it under a PHP or an ASP page. It should be privacy.html. In fact, I'm pretty sure there's compliance things that say it actually has to be called privacy.html. Okay, man, that's a lot of talking. Does anyone have any questions? Y'all got really quiet. tricky question because technically we compete with web app firewalls, but subjectively, let me just say this. It goes back, well, no. It can be used afterwards, though. You certainly have to do security early in the life cycle. That's a given. Web app firewalls suffer from the same problem that I was describing earlier. How do you detect layer 7 attacks? Because that's all a web app firewall is. And there are just so many ways I can mutate and hide things. You basically are left creating a baseline of what normal behavior is and flagging on anything that isn't normal. And normal is such a moving target, their effectiveness is questionable. So, I mean, do your own tests. If they work for you, if normal doesn't really fluctuate that much, maybe it works for you. And that really sucks to be stuck having to manage a bunch of legacy systems and not be given the resources to fix them. I'm sorry, but okay. So real quick, as people file out, web application malware is no longer theoretical. In fact, it's no longer proof of concept. We've got criminals actually writing it. So far, they've been silly. Expect this to change. And in fact, I wrote this in January, and sure enough, it's changed. You've got stuff that's stealing email, and it's harvesting, and it's being used for criminal purposes. And stealing email doesn't sound that bad, but 6 months ago, 8 months ago, it was Sammy defacing a site. Today, it's stealing email worms. How likely is what I'm talking about destroying the stock market or massively disrupting the internet? How far in the future is that? I don't know. I hope it's very far in the future. I hope we solve these problems. But I can tell you one thing for sure, web malware payloads are going to get worse. They are equal in terms of traditional malware in the amount of damage I can do in leakage. A Trojan horse can do as much damage as I inject keyloggers into your browser. For these reasons, first of all, web malware operates on a different level from traditional malware. We're in the virus, or we're in the application, we're in RAM, we're in JavaScript, we're in a database. For this reason, traditional defenses don't work. Because it's never written to a file. It's not, it's ID, or antivirus software says it protects you against JavaScript stuff. It protects you, when I download a code, that HTML file isn't passed to the antivirus software before my browser renders it. It's just rendered and I get screwed. It only gets scanned and it gets saved as a file. Because these defenses are not readily available, web application malware is actually more dangerous than traditional malware because you get the same amount of bang for your buck and nothing can stop it. No traditional offenses, at least, can stop it. Popularity and buzzwords are driving inexperienced programmers into the web application development, making these problems worse. I mean, we already have lots of problems. Go read full disclosure. Go read the pen test mailing list. Everything, 70, 80, 90% of the vulns coming out of, SANS are all SQL injection or cross-site scripting. It's moving to the web application space. Finally, properly securing your web applications, really it just comes down to input validation, and it will stop most, if not all, web malware. Does anybody have any questions? Oh, thank you.